Hello. So my talk today is about WebSockets, how to use them in the Angular apps. But myself, I work for a consultancy called Farata Systems, written several books, and the recent one is the second edition of this Angular for development with TypeScript. Slides that you see are here, so if you care, you can download them from there. So let's start. How many people used WebSockets before in any technology? All right, so we have some of you. So in this talk, I will start explaining the benefits of using WebSockets in general, so you will see why. And then I will show you some specific how we use them in Angular. And then I'll show you a demo of the app, which uses, besides HTTP protocol, it uses WebSockets as well. So that's the plan. And the whole talk is based on some examples that we have in this book that I showed you in chapter 13 in particular. The code is available, I'll show you on the last slide, but actually it's also on GitHub, so you can get it from there as well. Okay, so what is WebSockets and what are they for? First of all, it's a low overhead protocol, comparing to HTTP, of course. It's not a request-response based protocol. If you have two parties that needs to talk to each other, it's not like client always have to ask, give me something. Any party can initiate the conversation. Supported by all browsers, by all servers, it's standard. Uses the same ports. You can do port 80, you can do 443 for secure, so your system admins or whoever is responsible for firewalls, they won't complain because it's a standard protocol. You don't need to open up separate ports for that. And it allows bi-directional messaging flow of text or maybe some binary data between the clients and the servers. On this slide, I show you some examples of use cases where would you want to consider using WebSockets. For example, live trading, auctions, sports notifications. First of all, the keyword is data push. When you think that you need a server to push you some data, think about WebSockets. Maybe it's a candidate. Medical equipment, control medical equipment on the web. It would be too slow to make an HTTP request to the device with all these headers back and forth, so WebSockets is good enough. Chats, multiplayer, online games, right? Real-time updates in social streams, live charts. We are in New York, right? So Wall Street. Any pushes of financial data, WebSockets. So let's go back a little bit and talk about HTTP. HTTP is a half duplex, we call it, half duplex. Why it's a half duplex? Because I need to make a request over a connection, and only when the response comes back over the same connection, I'm getting back the data. It's not like the data going back and forth over the same connection. Request, response. That's the half duplex and HTTP. If you look at this picture, it's like a narrow bridge, right? The chicken or maybe the cars can go only one direction at a time. And then somebody will go back in a different direction. WebSocket is different. It's two-way street, so to speak, or a bridge where cars can go in both directions. So messages are traveling quickly, and literally there is no overhead. It's like 2 bytes overhead. And this is a quote from HTML spec editor from Google. He says it's reducing kilobytes of data to 2 bytes is more than a little bit more efficient, and reducing latency from 150 milliseconds to 50 milliseconds, it's more than marginal. So it is a huge difference, especially for the apps that care. And now let's talk about standard HTTP client, no Angular, standard WebSocket objects that is supported by all browsers. So in this example, as you can see, look at this red arrow. What do? I declare a variable and I create an instance of new WebSocket, and I specify a URL. I'm saying to this client, please go there and connect to this server, this port. Please know that I'm not using HTTP as a prefix. It's WS WebSockets. Accordingly, if you would want to use secure WebSockets, it would be WSS. So I'm saying I know that there is a server and on port 8085 that supports WebSockets. So go ahead and connect over there. And WebSockets is event-based protocol. So if something happened, for example, you have a message. You write a handler, a callback, what to do if I'm going to get a message. Like in this line, WS on message. So when message comes in, I write a function to be executed. Like in this example, I am saying find some element on the screen. I gave an ID, message goes here, right there, see this pen with this ID. And I'm saying you receive some data inside of that event object, so just put them in that span. Another callback over here, WS on error. What do you want to do if error happens? If error happens, you will get a callback invoked. And that's in the file simple WebSocket client HTML. In this case, on this slide, I show you a server. Again, it's a simple server. I'm using Node.js in this example. And in this example, I want to show you that the server, first of all, I start them. The server reacts on the connection request. See, again, event-driven, like WS server on. If the message is connection, what do I want to do? I'm going to get a reference to that client that connected to me just now. So I can send back the data to this specific client. If I have more than one client connected to me, this server will maintain automatically. It'll maintain a collection of all clients. So if I want to broadcast to everybody, for example, I can do clients.forEach, and I will push the data to everybody. But in this case, I'm sending data back to just one client. How do I create it on the Node server? There are different packages that Node supports. The one that I was using is called WS. You can download it from npmjs.org. And what do I do here? First of all, I start a regular HTTP server, and then, on port 8000, and then I start the WebSocket server on port 8085. I could have started both of them on the same port if I wanted to. So two servers are up and running. And how the whole protocol works. First of all, the client makes initial requests using HTTP saying, not HTTP. HTTP request is done initially when the client downloaded, when the page itself was downloaded. And then I make a request using this WS server port. So the server gets it and it sees, oh, they want different protocol. They don't want HTTP, they want WS. And this is called handshake. If the server supports WebSockets, it'll do something that we call upgrade of the protocol. If you will be looking at down there on the right, if you will look at the Chrome Dev Tools, over there you can see under the Network tab, you can see in the headers that there was a request, WS localhost 8085. It was GET request, and status code is 101, switching protocols. From now on, we are saying, from now on, no more HTTP. I'm going to be talking using WebSockets protocol. So upgrade happened, and then we can push data, and the server can push data back to us. And to run this example, I will go to my IDE. I use WebStorm, and what I will do, this is the server. I have two separate projects. One of them is for server, one of them is for client. For now, I'm not even using Angular at all. I will be using that simple HTTP client talking to Node. The only thing is that I use TypeScript. I develop in TypeScript. So on the server, if I would start from scratch, I would need to run command tsc to compile TypeScript into JavaScript, and then I would use Node to start the code. My TypeScript compiler is configured to produce output in the folder build. That's why you see over here that I'm starting this code from the build directory. As a matter of fact, I can compile it again, even though I already have it compiled. It compiles every file with extension .ts into files with extension .js, and I see I have them over here in the build directory. So the next thing is node build, right? And then which one I want? Simple WebSocket server. Simple WebSocket server. See, I started them. HTTP server runs on port 8000 and WebSocket runs on port 8085. Done. Right? Next, what do I need to do next? I need to open up the browser and I need to open it up on port 8000. It's an initial web page. I just need the HTTP to get it. And as soon as it gets loaded, it automatically will issue a request to WebSocket server. As soon as it'll issue a request, WebSocket will immediately push. It will not wait for a request for data. It'll just push the data. So I go to localhost 8000 and see the message was pushed by the server. If you open up the browser's console under the network, we can see it as well. There is this little tab, WebSockets. Actually, let me go to all first. Let me refresh the whole page. See, this first local host is my initial HTTP request to load the page. But the second one, look at this, it's status code 101. If you click on it, you will see the headers, what was pushed, 47 bytes only, the whole message. In case of HTTP, like 300 bytes extra headers on the way there, 300, 400, 500 extra headers on the way back, but over here, nothing. 2 bytes. And if you go to, and this is the frame tab, right? On the headers, you can see that switching protocol happened. So now I can talk using WebSockets. Next, if we have an Angular client, I forgot to ask you guys, are you guys all Angular developers or no? Please raise your hand if you're not. All right, only a couple of you. So basically, in Angular, you can deal with WebSockets in 2 ways. Case number 1, just use standard browser-supported WebSocket object. Angular doesn't give you any special wrapper, so you can use what exists in the browser. And case number 2, if you work with Angular, you definitely have RxJS installed library, one of the dependencies of Angular. Reactive extension library is there. And RxJS has a special subject, special class, called WebSocket subject. So if you want to have a better and easier way to work from Angular client with a WebSocket server, this is the way to go. But once again, if you don't want, just work with standard WebSockets. So let's look at the standard way of working. First, how you can take an object, a WebSocket object in the browser, and wrap it into an Angular service. Angular service will be injected in some Angular component, and we will use API. That's what we will try to do now. So that's the diagram of what we are about to do. So server, in our case, it's Node.js. Client, it's an Angular client, right? Then we will have WebSocket service class, where we will encapsulate all communication with the Node server. This WebSocket service is injected into component. Standard Angular model. Let's look at this code example. How to wrap WebSockets into Angular service. So class, you create a class, standard class, declare a couple of variables. One of them, socket is open. I define the constant 1, because they have, WebSocket has so-called ready state. If the state is 1, it means that the socket is open. I just need to know at any given time that it is there. Then what do I do next? See, I declare the variable of a standard browser's WebSocket. I create a method create observable socket. So the client will invoke this method on my service, and they will give me this URL, like, for example, WS localhost 8085. So what do? When I get it, I create an instance, again, standard WebSocket object for this URL. It'll connect to the server, and what do? I return new observable. Observable is a class from RxJS. There are different APIs of how you can create observables, and one of them is you could just create a new instance of the observable, and you specify an observer who's going to be dealing with the data that will be coming over this observable stream. You're saying observer, and on the observer, you kind of map events from WebSockets to actions that observable can do on the observer. I guess you remember, right? If at least 90% of you are Angular developers, that observer have only very clean API. 3 functions to call. Observable can send the next element, it can send an error message, or it can send a message that the stream is over. Accordingly, an observer has very clean API. You can call next on it, meaning here's your next message. Error, meaning here's an error message, and complete, here's an end of stream event. So WebSocket is based on events, and the observable is based on these kind of events. So when the standard WebSocket object from the browser will get a callback because of on message, because it received the message. So what do I need to do? I need to take it and relay it over into observable stream to the observer. See, I invoke next on the observer. I just take the piece of data, I give it to the observer, and do whatever you want with it. Accordingly, if I get an error message from the WebSocket, I just take it and I give it to the observer. Socket was closed, I invoke complete on the observer. Another method, send message, I defined over here. This one is for sending data from the client to the server. If the client enters something and hits the button, then in this case, I take this string that the client entered, and I check if the WebSocket is open, ready state is equal that constant, which is 1. Then I'm saying send. I'm going to send that piece of data. 2 bytes will be added to the string, and the server will get it. Pretty much it. So in this case, I have this WebSocket servers.ts in the client's project. If you will decide to try it out, I have 2 projects. One of them is Node, that I already showed you, or maybe not. Maybe it's a different one, maybe not. And the other one is Angular project. So this is a client. Now let's take a look at the component. Previous slide is a service, Angular service. We will inject that service into component. So inside that component, I inject this service that we just looked at. And in the constructor, I immediately invoke this create observable sockets on this service. Connection is established, and I do subscribe right away. So now I'm ready to consume messages that may be pushed to me from the server. So, and if I want to send message to the server, this is a client component, right? So I created a method send message to server. What do I do in this case? I'm trying to send a message hello from client, and I'm going to get back the response. Maybe I did, maybe I didn't send the message. I put it to the variable status. Status is here. Maybe I will bind it to the UI so the user will see the status. Close socket. If I want to close the connection, or actually if they close the connection, what do I need to do? If I explicitly created a subscriber in Angular, what do we need to do? We need explicitly unsubscribe. Where do you do it in Angular? In ng-on-destroy, right? One of the lifecycle hooks. So if ng-on-destroy is invoked in my component, what do? I invoke close sockets to clean up the memory, to make sure that the garbage is not left in memory. So that's the component. Now the server. What the server does. This file is called two-way WebSocket server TS. So very similar to what we did before. I create a new instance on port 8085. On connection, I immediately send hello from two-way WebSocket server. On message, I print on the console what I receive. This is the server's console. On error, I print an error, and on close, I can also print a message. And if the socket is closed, I'm going to get back the code and the error why it was closed. So if you will try to do this demo, I will start a different server. This one from the previous slide, and on the client, I will create this little app, WS service. So on the server, two-way WebSocket service, I will go back to my IDE, and I will hit Control-C. And in this case, it would be two-way WebSocket server instead of simple one. Two-way. Started on port 8085. Now I'm switching to a different project, which is a client project, Angular project. That's the one. That's the one. And I need to run the app called, I don't remember, WS service. I just have this project which is configured for more than one app. That's why I use this name of the app. And as a matter of fact, I have version 6 of Angular. In version 6, you don't have to specify this key, --app, if you have a project with multiple apps. So I just need to do this in gserve, WS service. So it's building the bundles. And then I'll go to localhost 4200 as usual. So the bundles are built. I will go to localhost 4200. Do you have any questions, by the way, while we are here? And see, on the left we see this nice looking web Angular client. So let me erase this part. And I can send message to server. It printed over here, but if I will go to the server's console, I should see message over there as well. The server. Yes, I received, the server received so-and-so. And I can, where is my network tab, WS? I would, let me refresh it so you will see it. So this is WebSockets, frames. See, in this case, when you work with standard Angular CLI app, they also maintain under the hood a WebSocket connection, but it's their server. But if I will click on this message, it's supposed to show me, but it doesn't at all. I don't know why it doesn't show me this on the network tab. Let me do disconnect. The socket is closed. Let me go back to the server. The user is disconnected. I am sending the error message why it was disconnected. So let me kill the server, and I will kill the client as well. And then now I will show you something else. How to use WebSockets with RxJS subject that exists there. The name of this class is called WebSocket subject, and a couple of words about subjects in RxJS. RxJS has observables that can push the data, but there is a special kind of nice classes, and it's called subject. There are different flavors of subject, but the main idea is that subject wraps inside observable, something that can push the data, and it maintains observer or observers. So a subject can be looked at both observable and observer. Moreover, if more than one client is connected to the subject, the push in one observable will be broadcasted to each and every client. So because the subject in RxJS is both observable and observer, it means that you can both invoke next on it and you can subscribe to it. In this little code under the hood, under the diagram, you see that I create a new instance of a subject. Then sometime later, I create a couple of subscribers. See, my subject subscribe, my subject subscribe. Then sometime later, I do push. I say my subject next. I'm pushing 1, 2, 3, and both subscribers will get this 1, 2, 3. You have a question?
I wanted to ask in terms of the timing of the connections. I saw in your previous code that you had assigned for the server to wait for a connection on 80, 85. Just as an example, does this happen like at the moment where, say, the browser hits a specific URL and the DNS does all that work?
The question was when all this happens in terms of timing. The answer is that whenever you make a connection to the WebSocket server, it gets a message connection. So if you will provide a handle on connection, this is when it starts listening. After that, if you will not be pushing anything to the WebSocket, so nothing happened. So it happens immediately when the client pushes the data to the server. Or if the server pushes the data to the client will immediately get notification. So you are in complete control. So RxJS, they took standard subject and they created another flavor of it. And this flavor is called RxJS WebSocket subject. So as you saw from my simple examples, the whole idea of WebSockets and their message-based communication matches or maps nicely to the subject. Subject also can push, and you can subscribe to it, right? So it's a wrapper around WebSocket object. So if you decide to use this RxJS class, you don't need to talk directly to the browser's instance of WebSocket subject. It's nicely wrapped inside. And it can accept strings, or you can specify, it can accept string with the server-side URL, or you can provide a configuration object to where, specifying where to connect to. And also on subscribe, the RxJS WebSocket subject will either create a new connection or reuse the one that's already there. It's also nice because you may have an Angular app with several clients that are interested in talking to that remote socket. So it can reuse the existing connection. On unsubscribe, if you say you have again a client, you will do unsubscribe. It'll check. Maybe there is something else who is subscribed to it. Then it'll leave connection. Otherwise, it'll disconnect if nobody cares. When the server pushes the data to you, and your client will be subscribing to this guy, like you would subscribe to any observable or to any subject, and this WebSocket subject will emit the data to your WebSocket, which is sitting under the hood, will emit the data into observable stream. And you, as a client, subscribe to the stream. Standard procedure. Accordingly, if there is an error, a WebSocket subject emits an error to subscriber, and if there are no subscribers, WebSocket can buffer the value. Here's a code example. The code example looks like this. I will show you, like in 10 minutes, maybe even less, I will show you a sample app which is online auction. I will show you a fragment specific to WebSockets when, imagine you look at the product and you want to bid on it. Meanwhile, other people around the globe, so to speak, can also bid on it. So you want to get notified immediately that somebody overbid you, something like this. So in that example, I'm using the bid service. I create bid service, and I am using this WebSocket subject. In version 6, they changed a little bit to the location of it, so now it's RxJS/WebSocket, the name of the module. So in the class, what you do is you say, here's my variable. I want to use this RxJS class WebSocket subject, and then in this case, I have a getter if somebody wants to get my reference to this subject. I am checking if this is the very first time when somebody asked for it. Sorry, if it's not negation. If it's not the very first time, or maybe the subject was closed for some reason, I will create it. And I will return it back. And then, for example, this is for placing bids in the auction. So I have some business application methods like price updates. If I want to listen to updates on the prices that come back to me, you can turn the subject into observable and subscribe to it. Or if you want to do place bid, what you do, you can call next on the subject, take the value from the UI and place a next bid. And now I will do a quick demo of online auction. The architectural diagram looks like this. In this case, I also have Node service with some data about the products. And it starts two servers. One of them is HTTP and the other WebSockets. WebSocket servers uses only for specific thing over here, for reacting to bids. If one client places a bid, everyone who is connected receives the latest price. The HTTP service in Angular is used like as usual. You create an HTTP connection, some business method, and in this case I have this product service with injected HTTP client, and I use it in several components. But we will be looking at this bid service part. And on this slide, I show you instructions how to run it if you want to run it on your own, but I will do it, of course, now. So first of all, again, on the node, I need to compile the code. It's in TypeScript, and then I will start main. I already compiled it, so I will just start main. On the client, separate project, I will go and do ngserve, and it'll load my app. So let me go back to the IDE. I want to open up the server, but this one is sitting under the ng auction directory. So main. I have several files. One of them is main. Main is the one that we need. So it listens on port 9000. Now I go to the client's project, which is sitting under the folder ng auction client. So in here, I will do just ngserve. It will build the bundle for me on port 4200. And then I load the app. When I load the app, what I will do, I will load it from two browsers, emulating two different users. I'll load it from Chrome and from Firefox. In one of them, I will be placing bids, and you will see how the second window sees the bids. So we are compiled successfully. Let me go back to localhost 4200. And this is my app. This is an auction app. I was using Angular material for this, which is not the subject of our discussion, but I went to product detail. As you can see, I have sunglasses and they cost $70. So when I will be clicking on the button, the price goes up $5 increments. It goes through the server, through the WebSockets. Right now there is nobody else, right? Only us. All right, let me make this screen smaller. By the way, over here I'm using the responsive web design using Angular's library Flex Layout. Very simple. So anyway, so I have it over here, and now I will go to Firefox, and I will connect to the same port, localhost 4200, localhost 4200, the same auction. I will open up the same sunglasses. See, the price is 85. New subscriber comes in, the server pushes right away the price. Now I will be bidding on the Firefox side. See, both of them see the changes in the price immediately. I will go bid on the second client. Everything is happening immediately. And the one WebSocket connection can hold like 65,000 clients. So I mean, it's very efficient. And finally, to wrap up this presentation, I want to mention one more thing. How many of you are working with messaging system on the server side, or maybe with Java? Anyone? No. All right. A little bit. All right. So I will just tell you briefly, so you know. Basically, if you would have a messaging system on the server side, some messaging queues, maybe topics, one of the commercial systems, and you want to use WebSockets with a web client, you may want to have this setup when the client sends something over the socket, WebSockets like I did, but you want to make sure that this message is automatically placed in a queue on the server side. And there is some process that picks messages from the queue and maybe does some processing. Accordingly, if the server side receives a message into the queue, for example, you work with some stock exchange and they executed your order, the order comes back to Java, for example, system, it places in the queue, and you want this message automatically will be relayed back over the socket to the Angular client. So there are special protocols, and one of them that is pretty popular is called Stomp. And it allows you to map easily. Say, imagine that you have a server with a WebSocket, and you have a messaging system on the server. You can map this, using this Stomp protocol, you can map this endpoint in the WebSocket to a particular queue. So as soon as the client will give something to this WebSocket, it automatically will drop into the queue. And accordingly, when another queue maybe will get some message, it will be sent over to the client back. So just keep it in mind, but I see that not too many people work with the server side. And that's all. Now I'm ready to answer some questions if you have any. Anyone? I also want to ask you one thing. I'd like to ask you to go to this BuzzJS.com and there's /experience, and please evaluate or rate my session or anybody else's session, so we would definitely appreciate your feedback. Any questions? Yes, please.
My question is surrounding authorization. Like, how do you deal? What's the best practice right now to identify where the, I want to say request, but it's not a request. But like the message comes from, like from the server's perspective, because like what if I have like say 20 clients connected, but I only want to push to like 5 of them.
Speaking of, the question was how to deal with authorization, and actually more specifically the question was how you can push specifically to some clients from the server, not to all of them. As I said, there are a couple of ways to do this. The simplest way would be on the server. WebSocket servers typically maintains a collection of connected clients. Like in your question, it was like 20 clients, right? And you can either loop through all of them and send to everybody, or you can loop through them and apply some functions that would check something about this particular user. And then you will decide if you want or you don't want to send these guys. Accordingly, when you are sending a message initially from the client, you need to send something that would identify the user. And you can make sure that not only the messages comes in, for example, buy me 100 shares of IBM, but also something specific to the user, the ID. So you can maintain your own collection of the users, and accordingly you can broadcast to only those who are supposed to get it. Other messages. Other WebSocket connections with me. Anyway, nobody wants. All right, then thank you very much.